Well, this week we want to talk about an article that came out in the news stack a couple days ago called let me share it real quick. Uh, the future of data engineering. So this popped up in my inbox and shared it with you very quickly. And so, yeah, this ends up being a pretty interesting article to go through. So that's what we're going to go through today. The future of data engineering.
Yeah, and it seems to align pretty well with our ideas about where things are going. So we'll riff on that a bit and probably disagree on a few points, but a lot of them we think this is pointed in the right direction, basically.
hmm Yeah. And I like how this article starts out with actually a quote from Frank Slootman, Snowflake CEO, who said, "IT leaders bore me." So we're going to get into this a bit. Definitely clickbait, but I think uh, there's some truth to the sentiment here. The article also references another post here from RudderStack. It talks about sort of the data engineering megatrend.
Yeah,
So it goes through a brief history. I think this is important context for kind of understanding the future of data engineering. So if we can go through this real quick. 20 years ago, IT owned everything, right? So IT is the gatekeeper. And
IT is viewed as a cost sink. That's another important concept here, I think, and that shows up peripherally in the future of data engineering as well.
right, yeah. And again, you started seeing the schism between IT and other teams.
Right.
I think this is correct around 2000s and 2010s. It's just things are moving too fast. The Phoenix Project is referenced here, a book that we definitely both like a lot. So
Absolutely. Yeah.
yeah. And then 2010 to 2015, the data engineer is born, and everyone gets their own software. This was definitely a big shift.
Yeah.
So
And I mean, in some sense, it was probably born before that at places like Google. It just took a while for that to disseminate out, and especially to disseminate out to Fortune 500 companies and banks that have very established IT practices.
yeah, exactly. And so after that, you start seeing a boom in software. I mean, kind of decentralizing purchasing decisions to teams. That became a thing in vogue, and I think it's especially with the pandemic, that's only increasingly become more and more. I think a thing. What we're seeing now is, sort of what this headline points to, which is the rise of the data engineer and data tooling, where teams now are able to choose their own tooling. IT, depending on the type of company you're talking about, may or may not have much of a say in any of this because it's not really their concern anymore. So.
Right. Yeah. And I mean, arguably in some companies, I mean, does Google have the concept of IT in quite the same way? Maybe not. I mean, they have teams that manage cloud infrastructure and they have teams that provide cloud services, but I don't think though they would call any of those just IT. I think IT was this concept of just this infrastructure team that takes care of certain systems for you versus teams that actually generate value and are a core part of the business, which is a huge shift here.
Mhm. Yeah, I think if you're talking about a company like Google, maybe the IT department like orders laptops for new hires and stuff and takes
That's
care of
true. Yeah, they're still
that
going
kind
to
of stuff, right?
include
But
that.
yeah, but I mean, I can't see them, developing like TensorFlow or anything. So,
No,
um,
exactly. Or running Google Cloud for that matter, right? Like that's going to be
mhm.
a specific division that's some long term, hopefully a moneymaker for them. So yeah,
Yeah. But then it starts talking about too, with something we see quite often, the crisis of integration, right? So everybody gets their own tools, which means everyone gets their own silo.
yeah,
And this is a genuine problem. So the big trend is going to be consolidating all this data, together and getting rid of silos. Um, so empowering teams with the best tooling while maintaining a unified, flexible data layer has become a central technical and operational challenge for almost every business. Hence, data engineers are the center of the action.
yep. And it's interesting because some of the trends are working at cross purposes here. So one of the big trends that was supposed to make data easier was the emergence of software as a service, right? So things like Google Analytics or Google Ads or Facebook, where they would kind of manage all your data for you in that platform. Well, the problem now is that you need to get that data out to like start merging data between the different ads platforms. And then you need to merge that with your core business data. And then you have numerous other SaaS platforms that you're dealing with as well.
hmm
And so this isn't meant so much as a plug. I think this is a trend we saw years and years ago, but companies like Matillion and Fivetran that deal with data integration, both potentially internally across silos and teams, and then with SaaS, that's going to be a growing market in the future. It already is. I mean, even a couple of years ago, you could see so many of these companies sprouting just to deal with that core problem.
Mm-hmm. Yeah. Yeah, it's only going to get bigger.
Yep.
So let's go back to the future of data engineering article. So let's look at some of the mega trends it talks about here. The first one is data roles will get a board level seat. What are your thoughts on this?
Oh, absolutely. I mean, and again, I feel like Amazon and Google were the trendsetters here because Google's business fundamentally was data, and Amazon's initial business was retail and selling books. But very quickly, they decided that that was going to be focused around data and built out. If they didn't have a C-level seat, at least there was that level of responsibility inside of Amazon and Google, where the data was considered a core function of the business, not something peripheral, not just for analyzing the business, but actually a core function of the business. And so I think to this argument, we'll see that actually reflected in board seats, and we've already seen it in various companies in the near past.
Yeah, I mean, a lot of the companies that we deal with, I mean, they're now hiring for new roles such as head of analytics, head of data science,
Right.
head of data engineering. It's another one, and then obviously chief data officer,
Chief
and
algorithms
then
officer.
chief algorithms officer. Yeah, so and I suppose these titles will become more fine-grained as as these companies gain more experience and get more value out of data.
Yeah,
So.
I think another argument here, though, is that the duties of this type of role are shifting a bit away from traditional data science toward kind of a more holistic view of data that includes data engineering.
Mhm. Yeah, for sure. I like this quote. As the
Yep.
lines between data science and data infrastructure blur, data and ML engineering roles will replace data science hires as the most sought after hires. Data science roles as sought after hires. We're seeing this, I think, anecdotally
Absolutely.
right now. So we talked ad nauseum about this, but I don't think we can talk enough about this trend. A lot of the attention right now is on data science. I think only recently are you starting to see, um, the focus shifting towards data engineering, just because it's hard to do data science in a vacuum without, proper infrastructure and pipelines.
Right. And it's all about integration, right? I mean, how do you actually integrate those data scientists into your business? Well, it's ML engineers and data engineers that let you actually do that. How do you get the data for them so they're not like directly accessing the Facebook API themselves and wasting a lot of time trying to write that code? Well, that's the job of data engineers as well. How do you make sure
Right.
that the data is delivered on a production schedule, not just like in one-off drops? Also data engineering.
For sure. Another trend that this article points out is dedicated data engineering support for every team.
Right.
Again,
Yeah.
data's first-class citizen across multiple teams. I don't really care what team you're in right now. If your company isn't, or I guess hasn't embarked on their data journey yet, you might want to ask when that's going to happen. And if you can't get a clear answer, I think our advice is maybe find a company that is a bit more data savvy or is going to start on this journey, just because of the fact that the companies that aren't going to be data focused and data literate are going to be dead.
Yep, absolutely. Absolutely. I mean, maybe you have some tiny niche somewhere where you can hide out and exist and continue to be a business. But for the most part, if there's intense competition, then your competitors are going to be working on data. So you'd better be doing the same thing too.
Hmm. Yeah, I
I,
like this quote too. What's that? Sorry, I interrupted you.
Oh,
What you say?
I was just going to say, I mean, the situation with data science kind of reminds me of the invention of the automobile, right? So in Europe, you had the invention of gasoline engines and diesel engines, and then people were building cars by hand, and they were very, very expensive. And then in the United States, you had the Model T and this notion of an assembly line and streamlining everything, right? And building cars at scale. And I don't know if Henry Ford was the one to invent the assembly line, but certainly he popularized it and used it very successfully in business. And I think we're seeing something similar with data here, where data scientists are more like people building cars by hand, just kind of hacking pieces together,
Hmm.
very expensive, sometimes very valuable, sometimes not. And with data engineering, you're streamlining all those processes to create more of an assembly line where you're going to deliver value much more efficiently from your data.
Hmm. Yeah, for sure. I mean, on that note too, this quote here, instead of asking how can we use data to make this better,
Yep.
teams are partnering with data engineering to ask how can our data and data systems shape the way we think about solving this problem. So very relevant.
Yep.
Um, another mega trend, an increasing number of unicorns solving data problems.
Yeah.
Definitely. There are quite a few of our partners actually. So, and rightfully so. This is I think the data tooling space is just getting started.
Yeah, absolutely. Absolutely.
Hmm.
It's interesting. I mean, I think these companies will sort of be the oracle of this generation, if that makes sense. So, of course, IBM developed back in the day in the 70s relational databases, but it was Oracle that really made them the core of so many American businesses in terms of managing business data. And we're going to see data pipeline and data warehousing companies and potentially things like Databricks become that core in the future.
Yeah, yeah, for sure. And then you have other things like points out Fivetran, DBT, Looker.
Yeah.
I would say for the latter two, especially, it's interesting because we're going to talk more about this, but these types of companies tend to be more batch oriented as
Mhm.
well, and I'm very curious to see how they're going to adapt, in an increasingly real time world. So,
Yeah. Yeah, absolutely. That's a very good thing to raise. I mean, I suppose the companies that are really going to do that well either have some steps to take in terms of their technology or just haven't been founded yet. Or maybe they've
mhm.
been founded, they're off the radar. But yeah, there are going to be some big unicorns in that space that we've never seen before.
Yep, yeah, they're all probably getting started right now too.
Absolutely.
Um, yeah, another mega trend, technology for moving data will become commoditized. I'll make an argument that a lot of it is commoditized now. The thing you don't have right now is sort of that unifying layer across
Yeah.
everything. So, um,
Yeah,
yeah,
it's funny. I
it's
mean, it's treating data as holistic, right? I think 5 years ago, data engineer was focused on like running a Hadoop cluster, and tomorrow's data engineer will be focused on like the entire picture of business data across the organization.
hmm yeah. I mean, this is a good sentence here. Competition will decrease the premium that companies can charge simply for solving a hard problem, right? Moving data between point A and B was hard, and there weren't many options, but increasingly there are more options, and these options will become more cost effective, definitely. I mean, we even saw this, several years ago, just with kind of the advent of again the tools we usually plug, Fivetran, Matillion and whatnot. I mean, these are I think early entrants in what's going to just continue to be a growing market, and it's not just going to be like moving data from point A to B. That's going to be table stakes, but really, I think our prediction is you're going to be moving data and solving uh, specific problems for people with that data. So, because
Yeah.
again, the big problem, as you pointed out earlier, is that yeah, you can move data from point A to B, like marketing data. You still got to join that all to various other data sets, and like you know that's a challenge.
Yeah, you have to normalize it. And ideally, you handle a lot of the joins and you standardize filtering so that your business metrics and things that go out to ML engineering are very standardized.
Hmm.
Non-standard data is a huge problem. People doing joins in non-standard ways, people not filtering properly, different types of events cause just great mismatches between different parts of the organization. So yeah, standardizing that is a very important problem to solve.
Yeah, I would almost say the data quality issues are the ones that are that to me is actually one of the more fundamental problems that does need to be solved
Yeah,
before you get any value out of these sorts of systems. Uh, but that's a topic for another day. So,
yeah.
um,
I'll just make the remark. I think organizations work on data quality. I think we need a more agile way of handling data quality, by which I mean you have to assume that your data quality is always degrading 24 hours a day. Things are changing behind the scenes that are going to mess with your data
mhm.
quality. So you need ways of
Yeah,
monitoring that
and that's why
constantly.
some of our friends at like Great Expectations and
Yep.
Y Labs and
Yep.
and others are I think doing a great job of focusing on this problem just because it is like such an atomic level problem that you do need to solve this before you can have all the data pipelines you want if they're shuttling crap data around, it kind of doesn't help at all.
Exactly.
So
And you
yeah,
look at like a Netflix. I mean, they post a lot of engineering blog posts about internal practices, and Netflix is big enough that they can build it themselves. And a lot of those posts are about practices around data quality and data communication. But at some point,
yeah,
there are the outside companies that are doing the same thing. You could sell it to corporate America, for example.
hmm yeah, it's gonna be a big change. Let's talk about another mega trend, real time or near real time infrastructure will become standard. Yeah, I would say it's standard because it's going to be the expectation.
Yeah,
So we always come back with, some of the questions about like, what are you going to do with real time, right? I mean, real time analytics, but I think the consequences of that are going to be more automation, really. And again, this is a sponsored post, by the way, so just but take it for what it is. I think these are some pretty good highlights,
Well,
no
and we
matter what.
agree with these things, and we are not partners with the authors of this article. It just happens to really
Right.
us. Maybe we will be someday, but like we think they're very much on the right track.
Uh-huh. Yep. Yeah, and there's probably a multitude of other things that weren't covered here, which we've probably covered in other videos or we'll cover in future videos, just because
Yeah.
the space is changing so quick in data engineering, and um, it's only getting more and more popular. It's interesting on LinkedIn right now. I mean, I, just seeing a lot more articles and posts about data engineering. From people that are mostly writing about data science. So
Yeah,
it's
I
an
think
interesting
there's
litmus
final
test.
recognition that this is absolutely needed for people to do their jobs in data science.
Hmm. Yeah, and even some of the office hours that we do too. We get a lot of questions about data engineering related topics. How do I move data back and forth? How do I host models? It's more kind of an ML engineering thing, but regardless, yeah,
Yeah.
it's interesting.
Yeah,
So,
a lot of these questions are about core skill sets. Should I be learning R, Python, or SQL, for example? And these are very
mhm,
much, as it turns out, data engineering type questions because these choices determine which types of systems you can interact with. For example, if you're using Python, then typically there are exceptions to this, but typically you're dealing with small data. If you want to deal with big data, then you need kind of a different set of tools. Even though your core statistical and data understanding is transferable, you need to know the details of the tools that actually allow you to scale up the data engineering.
mhm. Yep. Yeah, and my advice to people, who want to get into it, just again, focus on whatever the fundamentals are, right? Like, how do databases work?
Right.
I don't think that's going away anytime soon. At least, maybe different flavors of databases will come out, but you still got to know how they work. Um, and just obviously, like we say, skills like SQL and Python and so forth. But yeah, and so I mean, is there anything else that we can think of, that this article didn't touch on with respect to the future of data engineering?
That's a good question. I mean, it doesn't directly address, I think. Well, it kind of talks about the cloud, right? But I think that's another trend that it doesn't emphasize quite as much. But the fact that so much data is moving to the cloud, and that's because in the public cloud, you can scale so much better than you can in your own infrastructure, unless you're a really massive company that can build huge data centers distributed across the world or the United States at least. Yeah.
Hmm. Yeah, I totally agree. I think another intersection is going to be just software engineering, data engineering, and then data science, right? So maybe before we started, I was showing you, basically just let me show real quick.
Yeah.
So over the weekend, I'm just dorking out with an app, and I was digging more into Firebase. It's something I think we'd looked at a couple years ago, and it's like, oh, okay, so what would be an easy way to host an app, for example, right? You start looking at what they're doing here. Okay, so I can host my code. I can host my application. I can have a real-time database backing it. I can have machine learning integrated with my product. It doesn't show it here, but I can also send data into a data warehouse, BigQuery, because this is in GCP.
Yep.
I can run serverless cloud functions. Um, I can again store my data in object store and so forth. And at the end of the day, I'm looking at this like, okay, there's like there's definitely some crossover with data engineering, um, application development, software engineering, and then data science. So I thought this is interesting. It's Firebase has been around for quite a while, but I was definitely reminded like this is kind of where the future's heading, right? I think the distinctions between a lot of these things are just going to be increasingly blurred because
Yeah.
it's going to be table stakes really. It's not like there's this artificial distinction like data science is sort of a nice to have, right? Like you're going to be doing machine learning on any new product that you develop most likely. And so the fact this is integrated as like as a first class citizen is I think definitely speaks volumes to where things are going.
Yeah. I mean, we're fond of talking about cradle to grave in data engineering, which means that your data engineers communicate effectively with the application developers to make sure that the data schema or semi-structured schema, as the case may be, is structured correctly to support analytics applications and machine learning downstream. And Firebase perfectly demonstrates this paradigm where actually you just integrate all the pieces together, and potentially you have maybe some data engineers or some analysts, but they all kind of work side by side with the application developers as and extensions of the same team in some sense.
Mm-hmm. Now, obviously, some if your application becomes more sophisticated, you're going to
Right.
need to split it apart and maybe
Yeah.
try something else. But I mean, this seems to scale pretty well for quite a few companies just using that. Plus, AWS has their own version of this called Amplify, and it does roughly the same sort of stuff. It just allows you to bootstrap an application very quickly, but you get some pretty sweet architectures behind the scenes. And I would say too, when we talk about skills, like the skills that you're going to need to operate in an environment like this, whether it's AWS or GCP, you got to have cloud skills, which means you have to be very cognizant of all the various options and tooling within that cloud.
Yeah, I would say also like the interesting thing here is that you can have a 10 to 20 person company that's built around one app that's very successful, that's going to scale up a lot. And normally a company like that would not be able to have machine learning or data engineering. And by building it in like this, they can do that until they become 1,000 person company and then start breaking out some of those roles in the future as it
Yeah,
really makes sense. So,
yeah, exactly. So yeah, it seems to be the future. I mean, I think our prediction just offline, we'll probably have a blog post or something about this, but it's just the blurring lines between all facets of engineering and tech and data. Like I think our prediction really, if you're gonna go out the next 5-10 years, is that these lines are going to be extremely blurry. You'll definitely have functional areas, but it won't be as siloed as it is now. I mean, it's sort of like it reminds me of that. Let me just go back to that diagram real
yeah.
quick of kind of the IT. Um, let me see. Yeah, sort of like IT owns everything. Like right now, um, like your sysadmins, if you still have those, if you're not doing DevOps, I mean that's kind of the people who hold the keys of the kingdom now, right? And but it all starts sort of upstream too, in a lot of cases. So your engineering teams might be, the IT teams, or pick whatever gatekeeper you want. But I think as you start seeing the lines breaking down between IT and other teams, you're going to see a lot of the same lines breaking down between just different engineering and data factions. So
Yeah, absolutely. Yeah, I mean, I think there's increasingly, just moving back to what we were saying earlier, I mean, if data is a core asset of the company, then that needs to reach into every part of the company fundamentally. And you can't treat software as completely separate from machine learning. They need to be part of the same flow, basically.
mhm. Yeah, yeah, exactly. Cool. I think probably a good place to close it out. A bit of a
Yeah.
shorter session than usual, but yeah, it's always good to see people thinking about the future of data engineering, and always fun to kind of riff on it. So
Absolutely. I mean, you think part of the problem, if you're working in the trenches, which we've both had jobs working in the trenches, you get so focused on what am I doing with Databricks today, or what am I doing with Snowflake, but sometimes you don't identify those trends and realize, oh, this things are evolving very quickly, and in 5 years, the picture will look very different. So even while I'm working in the trenches, I need to think about where my infrastructure is going to evolve in the next couple of years, and my organization on top of that.
big time. Yeah, I would say actually now is one of the more precarious times to be building data architectures in that sense, where things are changing.
Yeah.
So you do need to be cognizant of it's kind of where the industry's going and the trends are going, because you don't want to be you just don't want to be that company that's stuck on legacy technology, and legacy, that window is increasingly shortening. So
It's absolutely true. I mean, to be quite honest, we would probably even consider something like Amazon Redshift to be slightly legacy. I mean, they really have invested heavily to kind of catch up with the other competitors. But at the same time, the fact that it's, a distributed Postgres cluster under the hood still kind of holds back the rest of the architecture. And in 2015, Redshift was really the hot new thing. So what are things going to look like 5 years from now? I don't know.
yeah. Yeah, and it's interesting too, hearing a lot of the vendor pitches about how they handle real time, right? Because that's that's sort of table stakes now, at least the ability to handle it. I'm not saying real time is table stakes because a lot of people are still trying to figure it out, but your tool should at least advertise that it can do real time, even if that means micro batch. So yeah, I mean, those are probably some considerations, and maybe we'll make another video on this and talk more. Just kind of what are some ways you might be able to potentially future proof your architecture, at least for the next 5 to 10 years. So
Exactly. Yeah.
yeah.
And fundamentally means you can't fully plan for the next 5 to 10 years, but you need to plan for the evolution in some sense. You need to plan to be able to react to the new technologies coming down the pipe.
Mm-hmm. And that means focusing on the trends as well as the things that aren't going to change, right? So you have to have a really good understanding of what the fundamentals are in order to know the difference between what's ephemeral and what's mostly permanent.
Right.
So
right. Yeah.
and the litmus test I think we always use is like, what are the things that aren't going to change with the expectations of the business, right? Like a business is never going to want their analytics or their data more slowly. They're never going to want answers to be, increasingly more incorrect, right? And they don't want their data quality to keep like going to complete crap. Like, so if it's a thought experiment of like what's not going to change in terms of just expectations and needs. And if you work backwards from that, I think it's going to be much easier because the number of tools that are going to be coming out, the landscape is just going to explode, especially when you're looking at something like ML ops, for example, which is just we're at the very beginnings of that field, just blown up. So
yeah. And I mean, I think across the board, whether we're talking about data warehousing or ML engineering, we'll have more and more powerful tools that are easier and easier to manage and configure. We've definitely seen that with the cloud data warehouse space, where Snowflake is just so turnkey. You just turn it on, you can have clusters up and running in minutes, basically. And we're already starting to see that in ML as well. And that those trends will just continue to blow up in the next couple of years.
Oh, yeah. Yeah. And I mean, in a lot of these too, I mean, keep in mind, this is all batch oriented. Like we haven't even started talking about like actual real time yet, right? So continuous learning, for example, and other trends, which are just like still, fairly early, really. Yeah. So
federated
cool. All right.
Continuously on phones and all kinds of things are coming. Yeah. But yeah, it's been a great chat. We'll see you next week.
See you next week. All right. Take care.